Earlier in this course, we looked at predictive modeling and its importance to the business for accurate forecasting and planning. In this section, we will consider the benefits of assisted predictive modeling techniques and tools, and how citizen data scientists can use these tools and techniques to analyze any business issue or use case with forecasting, regression, clustering, and other techniques. These techniques can be used by citizen data scientists without the assistance of a data scientist, analyst, or IT staff member, and they will help every team member to make fact-based decisions and clearly identify issues and gain insight into business results in a way that is meaningful to their role. In a moment, we will see these tools in action, but first, let's look at the assisted predictive modeling process you will follow from beginning to end. This graphic shows the steps in the process, and it will help you to understand how analytical workflow and processes can complement and support your daily routine. Take a moment to read through the steps in the process, from selecting the algorithm technique to fine-tuning the resulting model. Keep in mind that as you prepare data, choose a visualization technique and appropriate analytical techniques, you will be guided by auto-suggestions and recommendations to help you compile, analyze, and present your data in the best way possible without guesswork. The auto-insight approach to assisted predictive modeling simplifies the analytical process even further by working automatically on various possible algorithm techniques based on datasets and features, and then presenting the users with the most relevant, best fit algorithm and results, and with visualization and insight presented in simple language. Users simply have to choose a dataset, and the system will find and present the best possible insights from the dataset with simple interpretation and meaningful visualization. This process utilizes predictive modeling techniques to reduce the time and skills required to produce accurate, clear results quickly and dependably, and it leverages machine learning to collect and analyze data with the guided assistance of a smart solution. Auto-insight lets the citizen data scientist bypass the selection of data columns and analysis techniques such as classification or clustering. Instead, you select the dataset to be analyzed, and the system interprets the dataset, selects important columns of data, analyzes its type and variety and other parameters, and uses intelligent machine learning to automatically apply the best algorithm and analytical techniques and provide data insight. Auto-insight understands data and applies correlation, classification, regression, or forecasting, or whichever technique is relevant, based upon the data the user wishes to analyze. Results are displayed using visualization types that provide the best fit for the data, and the interpretation is presented in simple, natural language, and insights that users might otherwise miss will be automatically reflected and revealed for clear results. This seamless, intuitive process enables business users to quickly and easily select and analyze data without guesswork or advanced skills. Next, we will review the augmented analytics tools that will serve as a foundation for the citizen data scientist approach to self-serve data analytics environments. This review will provide an overview of the tools, and here you will come to better understand how your role as citizen data scientist can help you to effectively execute your responsibilities within the organization and become a true asset to the business. The Smarten Augmented Analytics Suite is comprised of a number of primary functions, including self-serve data preparation, smart data visualization, and assisted predictive modeling, or plug-and-play predictive analysis. With self-serve data prep, you can connect to various data sources and mash up data, enjoy auto-suggestions to identify relationships, joins and typecasts, and other opportunities for data transformation and cleansing. You can also explore, clean, shape, and reduce data, and combine that data, and you can perform comprehensive data searching and profiling. These tools enable a clear picture of data lineage and provide tools for collaboration, IT certification of data, and new and improved workflow and data governance. Smart data visualization includes auto-suggest recommendations to help you visualize data in the best possible way based on the data type, the nature of the data volume, data patterns, and data dimensions. The assisted predictive modeling tools enable users with simple tools and processes and walk them through the process to choose a dataset, a type of algorithm technique like classification, forecasting, or clustering, and then the system automatically recommends the best fit algorithm and presents the citizen data scientist with results and visualization to interpret the data in the right way. As you can see, these tools allow the business user to prepare and analyze data without the assistance of IT staff or data scientists, and without professional knowledge of sophisticated algorithms and analytical techniques. Users with no data science background can create, share, and use predictive models in minutes. In the first example, we have created flight data, including considerations for arrival, departure, the weather, and other factors. Here, we have transformed the data using self-serve data preparation to join flight data with weather data, and we now have a data set with information on all flights, including arrival and departure delay and weather parameters for arrival and departure of each flight. Here, the user can leverage auto-suggestions to create and view the right model for the data. The objective of this model is to analyze this data set to find the possible reasons and factors that might affect flight delays. With the data set defined, we will use regression technique with targeted variable arrival delays, and we will use predictors such as departure delay, snowfall at arrival and departure, and precipitation at arrival and departure to create a regression model and analyze results. After we choose this data and the regression algorithm technique, the system will work on finding the best fit algorithm and automatically present results and insights. As you can see, it has chosen multilinear regression analysis as the best technique for this use case, and the interpretation is provided in simple language, so the user can easily understand and use the data for insight. The analysis reveals what will cause or influence arrival delays. Here, the graphic depiction of the results provides a visual display of the departure versus the impact on arrival delays, and in the next graphic, we can see the consideration for precipitation. And if the citizen data scientist wants to dig deeper or take the initial analysis to a data scientist, the data scientist can use the technical model summary to start the next level of analysis. The next few graphics reveal the various displays and visuals that a user can leverage to see the data in a different way. Again, all of this is done based on the best visualization techniques for this type, volume, and nature of data. Keep in mind that once a citizen data scientist has gathered and prepared the data and created a model for analysis, other users can apply the model. In this way, users can collaborate and share models and data to gain insight and make decisions. Here, we see that weather and other factors will affect delays in flight departure, and that when the flight is delayed by 25 minutes, the arrival will be delayed by 56 minutes because of all the other variables we have considered. As you can see, with a few simple clicks, the user was able to get to the heart of the data, and the system did the work of selecting the right algorithm and applying the right visualization techniques and generating insights in simple natural language. Now, let's go back and choose the clustering analytical technique and select our data again, this time looking at which carriers would be the best choice to ensure on-time departure and arrival. Now the system elects hierarchical clustering as the best analytical technique. The displayed smile emoji tells the user that this is a good technique to use on this type of data. And here the data is revealed in graphic form for review, where the user can click on factors to turn them off and on and see the results. If we wish, we can change the columns we selected for analysis without starting over again, so the user can change considerations and variables on the fly. If the user wishes, he or she can turn off the auto mode to do some more manual tuning of the data analysis to change the clustering and the analysis. Again, this data can be exported and shared with other users to improve collaboration and productivity. In the next model we created, you can see that we want to predict the quality of red wine using a classification technique and dive into the data to see that there are certain variable paths that will produce a lower quality red wine. If I am a grape grower and wine seller, I can determine which parameters to focus on to improve the quality of the wine. Again, the interpretation is provided in simple, natural language, so the user does not have to guess at the results. But let's say I decide to use a different algorithm, one other than that recommended by the system. Here, I want to apply the SVM algorithm instead. You see that I am given a warning to tell me that this may not be a suitable technique to analyze this data. I'm going to use it anyway. So we'll apply this model, and the system will give us the best visualization technique to reveal the data in the best way. After that analysis is finished, I can change parameters and again look at the data by removing variables and working through the results to gain insight. In the next use case analysis, we see that the system has suggested the multiple linear regression technique to look at the cost of medical bills. Factors like the body mass index, or BMI, being a smoker or non-smoker, and gender can be applied, and here we will see the results. If we isolate the variables to choose a male, smoker, BMI, and other factors, you can see the results and how much the medical bills are likely to rise because of these factors. Insurance companies might use this type of analysis to determine which clients should pay higher premiums based on lifestyle and other factors. Let's look at the list of models we've created here. You can see that the system provides simple key metrics to show you that the model is a good model for the data you are analyzing by illustrating the ranking by the number of stars. In this case, the model is a 4-star model. So for those who are sharing models or reusing models, there is always a simple way to assess techniques and models to be sure you have what you want. This ranking approach also allows IT to assess the model and approve models and better understand what techniques and models are the most popular among users. In this example, we're using binary logistic regression to look at sales won and lost. And here you can see that the results displayed are easy to understand. If I want to change the data, I can isolate it in the Northwest region and focus on a reseller and other factors to determine what our sales team members should target and what they've achieved so that we can uncover issues with closing sales and solve problems and better predict sales results. In this frequent pattern mining analysis, we can create a picture of what products will most likely be sold together. And therefore, we might plan promotions to bundle products, and we might see that sour cream and milk are most often purchased together. Again, I can change variables to see whether a particular store location might stand out as unique in product bundling or sales. As you can see, creating the models and exploring the data is easy, so citizen data scientists can work through these analytics without sophisticated skills. And they can become more data literate and proficient, and thereby provide the best resource asset to the organization and have the tools to make the best decisions. If we look again at the benefits of predictive analytics and the various facets of the tools and decision foundation, we can see that these tools provide a solid foundation in which to employ the citizen data scientist culture and environment. This concludes the review of the augmented analytics tools. I hope this has helped to illustrate the benefits and ease of use, and to provide assurance that the citizen data scientist journey is not a difficult path, but rather a path that will offer numerous opportunities to grow and contribute.